All right, good morning. Hello, everyone, and thanks for joining our webinar today. If you have any questions during the session, please submit them using the Q&A button at the top of the interface. Those questions will be answered at the end. This webinar will be recorded and you'll receive a copy of it delivered to your email account. I hope you enjoy, and I'll now hand you over to our experts. Over to you guys.
Okay, hello everybody. My name is Tino Pyssysalo, and I'm working at a Qt company as the Senior Product Manager for the developer experience. One part of the developer experience is also Qt Creator, and that's why I am here. In terms of creating embedded software, we support in Qt, we support Yocto embedded Linux recipes. So those are publicly available, and anyone can configure them and create a Linux stack and install that into the embedded device. After you have created all the tool chains required, you have created the Qt libraries, you can create a kit, and that makes the building of further applications rather easy. We also have the Qt debug bridge, which helps you in debugging, of course, but also deploying software into the devices. Although then the different, let's say, real updates like over-the-air updates or nice updates to the cluster of several devices, this is something where we don't have yet good support. And we do have in our device creation offering, we have a boot to Qt concept where we have plenty of ready-made images available for a variety of development boards. So you don't have to build anything at the beginning yourself. You can use these ready-made builds, but the idea is that anyway, you never use these in the real product. You will replace with real self-made images, what you then use. But this is what we have. And now the idea is that at some point we will do a better workflow for the containers, providing this over-the-air support, for example. And let's look at that, how we could use containers to improve the complete workflow in terms of the tool chains, in terms of deployment, and so on. So our expert today is Burkhard Stubert from Embedded Use. He says he's an independent software craftsman. He has more than 25 years experience of embedded software, also mobile and desktop. And he's also an expert in QML, Qt, C, and C++. So Burkhard, please, the stage is yours.
Hi and good morning. So I'm Burkhard Stubert, and yeah, I built Qt embedded systems for a living. Have been building things like driver terminals for maize harvesters and sugar beet harvesters, or infotainment systems. So you can find the things I build in the wild. And today's topic is about how to build and run Qt embedded applications faster from Qt Curator with Docker. That's something that comes out of my daily experience. So let's get the things done. There we go. That's the one I'm looking for. So how do you build a Linux image or a Qt SDK based on Yocto? So what you do is typically you have a very fast workstation, something like the thing down there, 2 times Xeon, 32 cores, running probably Ubuntu 16.04. That's the one standing under my desk. And then you build, you set up a container, a Docker container, and build a Yocto 2.7. Well, for one product needs that. Or you build a Yocto 2.0 in another container, which needs an older version of Ubuntu, and so on. So you will have for each Linux image you build, you have a different container. You spin up the container, you build your Linux image, so bitbake, whatever the image name is, and then you build the SDK, bitbake, meta toolchain Qt 5, and after some hours, you have the Qt SDK. So that's totally normal for building Linux images and SDKs. And then the next step is, well, you have some application developers who write the actual application for your system. And how do they do that? Well, there are different options. Of course, you could try to build that on your workstation. Yeah, well, if you are also the application developer, like it's often the case for me, yeah, I can do that. But you see already, your Linux images or your SDKs are built on different Ubuntu versions. So you might have the green product here is well, it's fairly recent, not top modern, but fairly recent. It's Yocto 2.7 on an 1804 Ubuntu. And then you have a much older version of your system, the version 1.0, which is very old actually. And you might even, or your application developers might work on a different product, the application B. It's a different product, it's a different Yocto version, it's a different Ubuntu version for the container. And you might have a brand new application which is on the very latest Yocto, the Donfell, and a very recent Ubuntu version. And the thing to keep in mind is your Yocto version actually defines the Ubuntu version or the Linux version you can build on. You cannot build, say, a Yocto 2.7 on Ubuntu from 2020. Not possible. It's too new, and you will run into pretty funny errors. And the other way around, your Ubuntu might be too old for your Yocto version. So there's a dependency there. And what can you do for building your application, which is your actual product? You are not in the business typically of building containers and Linux images and Qt SDKs. You want to build the infotainment system of a car. And that's the applications in the top level. So what do? One option is, and that's probably the one used most often, you create, for every application, you create a virtual machine. And so, well, and you can, the guest OS will be the Ubuntu version you used to build the container. So it's the same basically, and you have to install probably the same packages you installed in the container. Then you install your Qt SDK in the virtual machine, and you set up your Curator, which is pretty much independent of the Qt version you use for your application, and then you can start developing your application. So, and you have to, you will see, well, you might work on different product versions, so that needs different virtual machines. You might even work on different products. So that's for a consultant like me, that's a very normal scenario. So I do a little, well, I work on a product for customer A and a little bit still for legacy product for customer B. And so I have a couple of virtual machines. And well, they are huge. So you can assume that each virtual machine has at least needs 60 gigabytes of hard disk space. So you can fit maybe 2 or 3 on your laptop or development PC. Besides the Windows virtual machine I always have on them. They are slower than containers, especially for when it comes to file I/O. They're a bit slower. I think something like 5 to 10% is the overhead you have. And you have a lot of I/O actually, because you compile, you create a lot of files and have to write them. So that is a bottleneck. And of course, your development PC is probably not as fast as your build server. So for example, my current application takes 5 minutes to build on my virtual machine. It takes 20 seconds on my build server. So that's why I prefer to work on my build server actually, and I have the luxury to do so, but not everyone has so. So the question is, why do you create a virtual machine? Well, it's definitely the builds are slower. It's a slower host computer than the workstation. And you also, well, you basically recreate everything you had in the container already. The container is a fully fledged Ubuntu system, and you have to do all the installations again. So why do you do that? So one solution would be, and that's the one I will look at in this talk, is to have the containers on your local workstation. So you basically keep the containers you already have from building the Qt SDK. And then you have, you run your Qt Curator on your workstation. That's the purple thingy. And you happily develop and you call your container for building. And so you basically for Qt Curator, the container is just a black box. Whether Qt Curator shouldn't bother which Yocto version is installed or which Yocto SDK is installed in the container, or on which Ubuntu version or Linux version the container is running. Qt Curator shouldn't care about that. There should be a simple interface where Qt Curator just tells the container, okay, now compile, now run install, now deploy the stuff to the embedded device. That's the only thing Qt Curator should know, and I'll show you how to do that. And well, obviously you can reuse the existing containers, and you can do that on your fast workstation. And yeah, okay, not everyone has a workstation, especially in companies. So what you would wish for is this, that, well, you work on your laptop, so you do your development on, say, Windows or on Linux or even on Mac OS, and you run your Qt Curator there and do your code changes, and then you hit Control R to build and deploy and run the thing on the embedded device. And when you build your application, well, what should happen is Qt Curator doesn't call the build locally on its computer, but it sends a request to a remote server, which is a very fast build server. And there, the container gets spun up, and the build is done, and then the results are passed back to your development PC. That's what I would love to have. We are not there yet, and I know that Sea Lion has that already, and it's actually, well, it's a classic. It's what is it called? Software as a service, I think. What you typically do, you build your applications, your systems on some fast machines in somewhere in the network of your company, or even well, on Amazon Web Services or Microsoft Azure or whatever, and you get the results back. And you do that for releases, for releasing your apps anyway, typically, and you do that for building SDKs, Linux images, and so on. And why not do it for your application? So that's what I would love to have, but we are not there. And I think Tino can tell you in the end what the plans for the Qt company are. So what's the idea? Well, the idea is a Docker wrapper for CMake. And if you look at how Qt Curator calls or does perform a native build, it's just a sequence of several CMake calls. So by now you have noticed I'm only do CMake projects, no QMake projects anymore. And we all have to do that switch with Qt 6 anyway. So it's a build, a native build is just a sequence of 4 CMake calls. So when you configure the project, that's the first one. CMake gets called in some temp directory, some fancy randomly chosen directory, and it calls. This is the typical command line here over there. It's with it generates Unix make files. And this qt settings.cmake file contains all the CMake configurations. In earlier versions, I think from Qt Curator 4.11 and older, you would see the actual configuration, CMake configuration variables, so the -d options. And now it's all nicely packed into this Qt settings, Qt Curator settings, CMake file. And then this is the path, public work, Qt radio apps. That's the path to the application. So it's actually a very simple internet radio. So that's the first call. Then when you hit Control B for building your application, well, CMake will be called in your build directory. So build Qt radio apps, then the kit name and so on. You all know that. And for me, it's in the public work directory. And it's this call. So it's actually pretty much the same as the first one, but in the build directory for the application. And then the compilation happens in the build directory, and that's the call CMake --build and so on. And that's just the compilation. And the fourth one is finally calling CMake with the install target. And in the end, that calls make with the install target because we generated Unix make files. So the idea is now, so this is, well, these calls look actually pretty good for what we have in mind, because, well, it's just CMake calls. So we don't know, Qt Curator doesn't have to know anything about what's inside the container. The only thing Qt Curator has to do, it doesn't call CMake directly because that would be on the local machine. It uses an indirection and forwards the CMake call to the Docker container, and then the CMake call is done in the Docker container. And that's the Docker CMake wrapper, which you see here. So it's a simple shell script. So instead of, so Qt Curator doesn't call CMake directly on your development PC, but it calls this script, which I called dr-cmake, Dr. CMake, no, Docker CMake, and which is placed in a path which is in your path variable. So it's Qt Curator can find it. And it's pretty simple. So the first line is just to please the gods of Bash, of the Bash shell, to resurrect some single quotes. Some genius had the glorious idea to have options with spaces. Thank you for that. But we can keep them. And then the second line, the Docker call, is actually the interesting thing. You run Docker, you run your container, you make the public work directory from the host visible in the container. We need that because that's where the build directory is. And we also make the temp directory visible in the container. So these two directories must be visible both on the host PC and in the container to work. Otherwise, it wouldn't work. And then the working directory is the current working directory as dictated by Curator. And then this is just the image name here, dr yocto SDK 1804. That's the name of my Docker container. And then the final two arguments are the forwarded CMake call. So it just forwards the CMake call to Docker and runs it in the Docker container. So that's in the right environment. That's the idea. And all that follows now is a lot of hard work to work around some problems here and there in Curator, in CMake, not so much in Docker. Yes, also in Docker. So it's now, I'll show you the details to get everything working. Prerequisites. So what do you need? So first of all, that's my setup. That's what I'm talking about. I have a workstation running Ubuntu 16.04. I have Curator version 4.12, but older versions would do as well. I have this internet radio you see on the right-hand side. That's the Qt Radio app. And then I've built a container which contains Qt SDK for Raspberry Pi 3. And it was built with Yocto THUD 2.6. And it's based on an 18.04 Ubuntu. So you see, it's not the same Ubuntu version as the host PC, which is a fairly normal setup. And you see on the right-hand side, you see a bit of actually when I hit Control R. So what happens here in the messages you see in Curator, and then it really starts the application on the connected Raspberry Pi. It's a proof of concept, so not everything works, but it's clear that it works well enough for me to use it for my daily work. So, but there can certainly be improved. So what do we need? So you need to install Docker on your workstation. I've written about that, so you see the references which are given at the back of the talk. You create a Docker container for Yocto builds. You either build an image with a Docker, a Linux image with a Docker container, well, for the Raspberry Pi, or that's pretty nice. You can also download a pre-built boot to Qt image from the Qt company, and you can and then the second step is you need to build your Qt SDK. With a Docker container, or again, you can download that pre-built boot to Qt SDK from the Qt company. And actually, Tino, my co-host here, or my co-expert actually, has given a nice talk at the Qt Virtual Tech Conference, where he explains how to set up an application development environment on a Windows machine, actually. So, and you can follow his talk there. That's the number 5 or 6, one of the two. And you know how to do that. Good. What you also need is you need a SSH connection between the workstation and the device, because Qt Curator will use this SSH connection to copy things over from the workstation to the device. So how do you set that up? How do you set up the SSH access in Curator, of course? So that's the final thing. What you will do is you will hit the add button here, and then you have a 3-step wizard which takes you through the setup of the SSH access. And in the end, you will see something like that. And so it has a name, your device has a name, Raspberry Pi. You can give a host name, or you can give an IP address. For me, it's an IP address. And the interesting thing here and the important thing here is that you can actually deploy the corresponding public key to your device. And then you can just deploy things onto your device without ever entering a password. If you use the password method, which you could do, you always have to enter your password, which gets a bit annoying. Well, you definitely know your password afterwards. So that is all. You can do all that from Qt Curator, which is nice. So, and Qt Curator even creates a private and public key for you, so it's all very comfortable. You have to install the Qt SDK in the container because, well, you are building against a given Qt SDK. The first thing is that is basically on your workstation. You start your container. You run your container in a shell. You run a shell actually in the container, and in the Docker container, that's the lower box here, you do the standard thing to install a Qt SDK, which you either build yourself or download it from the Qt company's website if you are a commercial customer. So you find that in temp deploy SDK, you run the shell script which is available there, and then you tell it in the end where you want to install it. And it must be again in the working directory, which is visible to both your host PC and the container. So that's pretty standard if you have worked with Yocto. And then the next thing is, well, before you can build in, before you can use the SDK, you normally have to source an environment setup script. And what this script does, it exports something like 20 to 30 environment variables. So it sets the native and the target sysroot, the compilers, the compiler options, and a lot more, which it needs to work properly in a cross compilation environment. And well, it didn't work out to to source this file just together with calling cmake in the container. That didn't work. And so the obvious workaround was, well, I just set the environment variables in the Docker file. So yeah, it's a pretty simple change. You change all the export things, names to env for environment, and I also changed the or enclosed the environment variables in curly braces in the Docker file, but I think that's not necessary. So it should work without that. So that's the first thing you do to set up the environment variables in the Docker container. And the second thing is given here. You will, if you ran a build now in the Docker container, well, CMake would already fail on detecting the compilers. So one thing that CMake does when calling it when configuring a project or building something for the first time. It checks whether the compilers are working, and that check will fail. And you will actually, if you Google, you will find a lot of questions regarding that. And it fails because Yocto, the setup script, adds the options. It adds some compiler options to your compiler command. So you see it here for the C compiler and for the CXX compiler. It adds some options about the architecture of your target device, and especially about the floating point support of your target device. And what happens with these compiler checks is that Curator sends only the executable name to CMake, not the options. So, and then CMake builds a little executable without the floating point support, but then finds out, oh, my my target system supports VFPv4, this floating point support, has this floating point support, and then says, no, that doesn't work. The compiler doesn't fit your target system. I fail, and it's over. Figure it out. So what you do here is, once you know it, it's simple. It cost me a couple of hours to figure that out. You set the environment variable in your Docker file. Just the C compiler is just the compiler name, and the C flags is actually what you have in the C flags already. There is some more, plus the compiler flags from your compiler executable definition. You do that for CC, you do that for CXX, and you do that for LD and CPP, this C preprocessor and the linker. So you have to do analogous fixes for all 4 tools, and then you're good to go. Then everything is set up nicely. And that's actually, that's not just, that's a good advice also when you, whenever you build a Qt SDK or build against a Qt SDK. So we have to configure Qt Curator. That is pretty simple, actually. So what we have to do is in the end, we have to define a kit. And you probably know this. You open Tools, Options, and then go to Kits. And you have to set the CMake you want to use. And that's fairly obvious. You want to use the Docker wrapper CMake, which is in my home directory bin dr CMake. You can browse to it and change that. And you give it a telling name, Docker CMake. That's CMake. Then the kit. So you see, okay, I don't set any compilers, didn't define any compilers, no Qt versions, nothing. And you see that reflected here. So you do not set the sysroot, you do not set the compilers, you do not set the debugger, the Qt version, the Qt make specs. That looks a bit strange on a first glance. But on second thoughts, it makes sense, because if you use a CMake project, you pass everything, every relevant information you pass through the toolchain file. And this is passed in the end in the CMake configuration. So that's important to understand. If you do a CMake-based embedded project, don't set the compilers, don't set the Qt version, don't set the sysroot. That all comes from this CMake toolchain file. What you should set here, give it a nice name so you can recognize it. It's a generic Linux device, which we set up earlier. It's this Raspberry Pi device. That's important for deployment especially. So now let's look at the CMake generator and the CMake configuration. The CMake generator is, well, I use Unix makefiles and code blocks. If you change, well, Curator had the fancy idea that I should use Ninja a couple of times. And if you change the generator, make also sure that you change the extra generator, because that is always set to nothing if you change the generator. Don't miss out on that. The CMake configuration file, that's the qt settings.cmake file you have seen earlier. It contains a couple of changes which are important, and which this is something you here it's the end product. It's the result of, I think in total it cost me about 2 days to figure that out correctly. By now I know. And it's a big fight with CMake and Curator, because they at the moment they have some problems in their communication, so they both want to be right. So the CMake CXX compilers and C compiler, that's the standard value, which you always have. It's ignored anyway. We didn't set any compilers. The CMake make program is necessary, is required to be set, because what happens in the compiler tests is that it uses the cross-compiled make version. Well, that can't work on an which would be an ARM executable, which definitely doesn't work on an Intel architecture. So that's one failure during the compiler detection phase. So you have to fix that. The CMake prefix path is important. That's CMake needs to know where to find CMake configuration files, like all the configuration files for the Qt modules. So that is the path, and it goes into the actually in the sysroot for the cross-compiled, so for the Cortex A7 thing. The CMake toolchain file, as I told you already, is the most important file. Actually, I think that should be the only thing which Qt Curator should pass to CMake. And on the command line, it actually works. So you can make that the only thing and nothing else. It contains all the information where your compilers are in the Qt SDK. It's cross compilers you need, where your headers are, where your libraries are, and so on. That is all in the CMake toolchain file. Then you have the OE QMake path external host bins. Well, that's a bug in the older Qt configuration files, which is fixed here. And without that, CMake doesn't read any Qt configuration files for CMake. So, and Qt QMake executables, that's not really necessary, but Qt Curator insists that it must be there. So, good. Use that. If you don't use that, you will run in a lot of CMake errors. And the thing you should know is how to fix that. What you eventually need, you will have to remove the CMake cache.txt, I think, in the build directory and in that temp directory from time to time. And there's also CMake file subdirectory in there, which you have to should also remove if things are completely messed up. And occasionally you should remove the options, the CMake options from the CMake list.txt.user file. So that's in the end five locations which influence the settings of the CMake variables. So so I learned it the hard way. That's the working solution, and it took me some time to get there. So we are getting closer to what we want to do. So we can now build the app. So we have a kit now, and we switch to the kit we just created. We click on projects here and on the left-hand side of Curator. Then the Docker Raspberry Pi kit will be first. It will still be disabled, like these down here. Then you click on the kit name, and then you click on build, and then you see CMake running in the general messages tab already. So you see some messages, and if everything works fine, you see these CMake variables shown up here. If everything works fine, normally you get some error messages. And what you see here, and that's good, okay, the build step is calling Docker CMake, our wrapper, and with the usual command. The same down here for the clean steps. It also calls Docker CMake. That's the messages you see when you switch to the kit. You see the compiler checks I've been talking about, detecting C compiler, check for working C compiler. That's all now working nicely. And in the end, it says build files have been written too. That's a thing when you can be happy. Then things worked. And up there you see it's calling our Docker CMake script with the usual options and arguments. When you hit build now, you will see these build commands. Again, it's important that it calls our Docker wrapper and forwards the call to Docker, and it really calls the CMake in our Docker container. And it all works, so it links, it compiles, and so on. That's all working. Even the time is working for a change. Normally it's just some random number. So, and now let's do the last step, deployment and running the app on the device. So we have to set up some run settings. And as I use, as my Yocto version is not the latest, the CMake version in there isn't the latest either. It's a CMake 3.12. So the CMake install command doesn't work as nicely as with later CMake versions, but it does the purpose. So I call here install, and install will install my executable in a staging directory. And then the next deployment step is checking whether the executable, that's the only thing I have to deploy, whether this executable fits into the required space on my target device. 5 megabytes is okay. Even the debug executable has only 380K. Then we kill the currently running application on the Raspberry Pi. And finally, we call rsync. And usually you have, Curator offers you an rsync step, and you don't have to define a custom process step, but the default one didn't work for me. And I guess it's because I used an older CMake version. So I have to check whether it works with a newer version. But the rsync call is pretty simple. You're just copying everything under the staging directory to use a local. Okay, and now the run settings. Yeah, you choose a custom executable on Raspberry Pi and have to fill out things. So my executable is in user local bin, Curator, you have to fill that out. The local executable is in the build directory, staging bin, Curator. Then it needs some arguments. So I use EGLFS as the windowing platform. And the working directory doesn't really matter, it's home root. Don't check the running terminal. I think it wouldn't work. And you could even set some environment variables here. And now the great finale, running the app. So if you hit Control R, you will see a couple of messages in the compile output. It does all the deployment steps. So you see that is the CMake install call here, the first one. Then it's checking whether it can fit the executable, the application on the device. Yeah, 461 megabytes free, that's no problem. It kills the application on the device. And then it uses rsync to copy everything which is under staging into the right place on the device. And you see here, you see it's sent over, and that's that. And in the application output pane, you see finally, yeah, it starts Qt Radio with the EGLFS platform option, writes some debug messages, some from me, some from Qt. And on the device, you would now see hear the radio playing. And from Qt Curator, you can stop the application actually. You can open a terminal on the device. You can see the processes running on the device. It's all pretty comfortable. And if you have set it up properly, you could even run your application in a debugger and debugging the application on the device. And just because it's so nice, I show you a little video at the end. So where you see it starts in black. So it's a black background here. And I change up here, it's a bit hard to see. The color is black. I changed that to blue. And then it recompiles the application and starts it on the Raspberry Pi again. So now I hit Control R and you see the messages coming through. Now it goes black, the Pi display, and comes back to, of course, I hit an advertisement break for sure. So yeah, that's it. Here are the references. The first 4 are from me on my blog, and the other 2 are from the Qt company. So 5 is the starting point for the Boot to Qt software stack, and 6 is the talk from Tino, getting started with Yocto and eLinux. And he explains in detail how to install a Qt SDK and run a very cool application, I think on an NVIDIA processor. So that's it. I say thank you and hope for many questions now.
Thank you, Burkhard. There are a couple of questions. I have one question before the other questions, which is commonly asked from me. That can you repeat again that what are the benefits of using containers compared to the traditional or other approaches?
Yeah, I certainly can. So it's actually in the motivation slides at the beginning. So you have a container anyway already because you built your Qt SDK, your Linux image with it, so you have that already. And so why throw that away and recreate everything in a virtual machine? So that's double work. That's one thing. That's people time. And the other thing is you want to run your application on a fast machine. So that's standard, or you want to build it on a fast machine. That's standard procedure for if your build takes 20 minutes on a slow machine, but it only takes say 2 minutes on the fast one. So it's pretty clear where you want to run that, and Docker container allow you to do that. So you get faster build times, and you can reuse what you already have.
Yeah. Very good, thanks. You created container applications for the Raspberry Pi, and there is a question that, is there any document on Yocto build for Raspberry Pi 3? I tried the things from QDocs on my virtual Ubuntu 18.04, and it always fails.
Yeah.
So yes, we do have a generic key documentation, but of course it has tested that or it has been built in the recipes that how to create the Yocto build. But what is your approach?
Yeah, so well, I did it myself because what Pradeep describes here is was exactly my experience as well. And you can actually find the answer in reference 3 and 4 here. So it's a start of a series I'm currently writing. And the first one is building the Linux image with Yocto, and it's exactly for Raspberry Pi 3. And the second one is building the SDK. And so you can start developing for your Raspberry Pi. And it builds an, well, for an EGLFS. So you also have OpenGL acceleration there. And that's, well, I pulled together, well, I use a couple of sources there. There is another project from a Swedish guy, from Erik Botu, sorry, QtPy. It's I'm referencing I think in the part 2 as well. No, I wrote about it in my newsletter. So that could be a source, QtPy, or the jump to Nowtech people have pretty good descriptions as well by now about building for the Raspberry Pi.
Good.
Hope answers your question. Poki 2.0, isn't it quite old? Yes, it is old, so that's probably thought, I think. And at the moment, I've built, yeah, I had that working or lying around, and it was working, and that's why I used thought. And I think my plan for this month and for part 3 of my series is to finally move to Dunfill. And if you look at QtPy, which I just mentioned, Eric has it already done for Dunfill. So yeah, there are newer versions. But on the other hand, it's the reality you see with customers. So one of my customers, the harvester manufacturer, they are still on Rocco, which is even older than Thud. So there you go, and you have the fun to upgrade the Qt version in an old Yocto version. And it's not that easy to update the complete Linux system in a harvester or in some other machines. So it's not something you want to do regularly, and that's why they typically have pretty old Yocto versions. So next question, we'll look from Bakyaraj. I hope that's halfway correct. We are looking something similar setup. Is the container Docker? Yes, it's a Docker container. Yeah. What about the Docker license? Should we need to buy Docker too? No, it's the community. So I did everything with the community edition of Docker. So as long as you stick to this edition, there is no need to buy the license, I think. So, any more questions?
Common question which is asked from me is that why Qt Creator doesn't have a support for containers, and this is just a resourcing system, the scale of resources that we have created containers already for different targets. So we have been playing with those, but they are not integrated in Qt Creator in any way. We do have plans still this year to support containers to do the cross compilation and to do the deployment to the target. But as we still have the resource problem. I don't give you concrete examples what we will have in the next quarter or in this quarter or on the next quarter. But yes, we will show our plans, and there definitely are plans to have container support, building and creating containers and using the tool chains inside them, and for the deployment. These are the things what we want to improve.
So what I understood from Tino before our talk was that they would like to come up with something like that, containers on remote workstations, but yeah, but they have a resource problem. So if you're looking for some very interesting job, a Qt company probably would appreciate that. And yeah, I know. So Sea Lion seems to have that working. So that's always a good motivation to get that working as well. So I think there's another question. Pradeep, does it also the same for boot to Qt? There is a, yeah, I think at the moment, Tino, correct me, boot to Qt doesn't offer Docker containers yet.
No,
but
no,
you
absolutely
can.
not. This is really what we are planning to be, but not there yet.
Exactly, but you can download the Qt SDK, install it on your Linux machine or even Windows machine actually. Then you can take it from there. So you could take the boot to Qt SDK, install it in a Docker container like I showed you, then it would be the same process.
Yeah.
From there on. Yocto build, okay.
I think Yocto build is related to the same previous question.
Yeah, so you don't have to, if you have a commercial Qt license, you don't have to build things yourselves. So you get a ready-made Linux image and Qt SDK from the Qt company. You can just download it, and there's also one for the Raspberry Pi and some other common platforms, so all the iMix X's and so on, and some NVIDIA stuff, I think. That's all there, so you don't have to build it yourself, which makes your life probably a bit easier. Is there a plan to improve CMake cross-compilation integration in Qt Curator? At the moment, it's easier to just use QMake. I second the second one, and the first question goes to Tino.
yeah. This is something what we have been, of course, doing quite a lot. So far we have been just improving the CMake builds in general, of course, because CMake will be the build tool for Qt 6, and the cross-compilation support hasn't been actively developed so much yet. But yes, the goal is, the plan really is that before we have a Qt 6.0 out, plan is November, December, somewhere there. We will have also the good support for cross-compilation. Yes, we are working with this.
And yeah, and it's constantly improving. So I started that two years ago. It was a mess, and it's getting better and better with every Qt release.
Yeah. Then there's, yeah, sorry. So this is to me, do I need a commercial license for boot to Qt? Yes, you don't need the commercial license to use the Qt Yocto recipes. You can use the Yocto, you can use the toolchains to build your own images, but boot to Qt contains ready-made images for you, and these ready-made images are available under the license. So then you have to have the Qt for device creation license.
Yeah, so the ready-made images are only available on the commercial license. The rest, if you want to build it yourself, you can do that. Just be aware that it builds also, I think, a lot of commercial packages. So if you want to stick with Qt under FOSS license, you have to remove these commercial packages. Think Qt Virtual Keyboard or things like that, or some automation stuff. Think MQTT, for example, that would be only commercially available.
Yeah.
Or
but for
on that
example,
GPL.
virtual keyboard also has the open source license, but it's GPL, and if GPL is problematic, then remove it,
Yeah,
or then
exactly.
you need a license.
Exactly. And for small businesses, there is now a small business license, which I, for example, also have for just $500. So it's getting better. Pradeep, yes, I wanted to build my own boot to Qt with open source Qt. Yes, so we just mentioned that. Yes, you can do that, but you have to be aware that you have probably have to throw out a couple of commercial Qt modules. They build boot to Qt gives you everything. Every Qt module there is, that's what you get. And then you have to go through the list and see, oh, that's commercial only, and then you have to throw them out so that you don't get into any problems. Unless you are happy with GPL version 3, then most of the commercial packages are also licensed under that. But if you go for LGPL, then you have to remove a couple of things.
Yeah, exactly.
Good. Yeah, I just looked at boot to Qt.
All right, I think we're running out of time now, and I think that was the end of the questions. So I'd like to thank Burkhard and Tino very much for the presentations and the talk, and thank you everyone for joining. If there are any more questions that comes to your mind after the session, you can obviously get in touch with us directly at info@qt.io. But thanks again for joining, and have a great rest of the day. Thanks. Bye.
Thanks a lot, and bye-bye.
Thanks. Bye-bye.